Today we'll be looking at the application of rules of inference. Okay, so before that, let's first of all write out our rules of inference. So these rules of inference will be a guideline to how we can solve arguments using the rules of inference. Okay, so the rules of inference. The first rule, modus ponens. And for modus ponens, says when you have P implies Q as our first premise, the second premise says that was P, therefore Q. Rule 2, modus tollens. For modus tollens, the short form for modus ponens is MP, while this is MT. P implies Q, not Q, therefore not P. Addition, ADD. Down says when you have P, then the conclusion will be what? You can add any other variable, P or Q. Absorption, ABS. P implies Q, therefore P implies open brackets P and Q. Now 5, conjunction. For conjunction, CONK, P our first premise, Q our second premise, therefore P and Q. So 6, hypothetical syllogism. HS. So for hypothetical syllogism, I have P hypothetical syllogism where I have P implies Q, and that same Q implies R. Therefore, P implies R. So 7, we have constructive dilemma. Constructive dilemma. So for constructive dilemma, we have, that is CD. We have P implies Q, with brackets, and R implies S. The second premise is given as P or R, therefore Q or S. So, rule 8, we have simplification. That one is SIMP. P and Q, therefore P. So the last rule is disjunctive syllogism. That is DS. For disjunctive syllogism, P or Q, not P, therefore Q. So these are the 9 rules of inference, right, that we are going to use to resolve arguments. Okay, So okay, see, in resolving our argument, we need to understand these rules. For each rule, for example, the ones that have two premises, whenever you are resolving their arguments, you must make sure that the two premises are present before we can derive our conclusion. You can't derive a conclusion with one premise using a rule that has two premises. Okay? So all this thing I'm saying, when we start resolving arguments, we understand. Okay? So let's take this example. Right? We have supposing we have A and B. Our first line, A or B implies Z. Okay, so A and B, line 2. A or B, no, A or C implies D. Therefore, A and D. So this is our argument. Okay, so we want to make use of these 9 rules to resolve this argument. So you go to our line 3. The first thing we need to do is look at this argument. In this argument, there are hidden premises and conclusion there. So what we just have to do, or what we are required to do, is to bring out those premises and the conclusion. And we are using these rules of inference to test the validity of this argument. Okay, we are using these rules of inference to test the validity of this argument. And here we have some hidden premises there, which we are to bring out. So how do we get to bring them out? We need to make use of these 9 rules. Now let's look at it from this 9 rules, from our line 1 and 2. You can see some resemblance here in these 9 rules. Okay, I want to start from line 1. Okay, I want to get my line 3 from line 1. Okay, line 1 says A and B. Alright? Okay, sorry, before I proceed, you see anything after this conclusion, any line you have after this conclusion here, whatever is written there is only conclusion. Don't get it wrong. I said anything after this line, after this conclusion rather, the next line will surely be the conclusion. Will surely be the conclusion. After you've applied any of these rules, will surely be conclusion. Okay, how will say conclusion? Let me explain. So I said line 1, A and B, right? Looking at it here, we have something that gives us A and B, right, as our first premise. Okay, but this is only one premise. So if you are to look at these 9 rules, you can see that it is only simplification that gives us away. We have P and Q, then we can infer that was P. So which means A and B, P and Q, therefore P. So you can see that after this conclusion, what I wrote here is a conclusion of this A and B, right? The conclusion of this P and Q, therefore P, A and B, therefore A. So you are now indicating that, okay, this my conclusion A is gotten from line 1 using the rule of what? Simplification. I hope you're getting it. So this is my A, and also this conclusion that you get can serve as what? As second premise, okay, for other arguments. Can serve as second premise for that in order to arrive at your final conclusion. Okay, so let's go. I've already used my line 1, using what? Simplification to get my what? A. You cannot say line 4. I've done my line 1. I need to what? Because the argument, the conclusion was A and D. How can I get A and D when my D is already trapped in A or C implies D? So I need something that will make me what separate this my D from here. Alright, so I already have my A, and there is a rule saying that when you have a given statement or a variable, you can add any other variable as a conclusion, which is what? Rules of addition. You say when you have P, therefore what? P or Q. So I have A. I can now say A or C. That is, I added what? Variable C towards this my line 3. Using what? Using the what? Addition. Okay, so like I said, that I need to remove, like to separate this from this. So which means I have to get something that is what? It's identical to this in order to remove what? This. So now, my line 5, I have my A or C. Okay? Line 2 says that what? A or C implies D. Remember that I said this, your direct conclusion here, can also serve as what? Another premise. Okay? For another what? Argument. So you can see that A or C implies D. This is my what? First premise. This A, say A or C, that happens to be the what? Conclusion of this is not serving what? The purpose of second premise for this in order to what? To separate this from them. So I have A or C, therefore what? D. How did I get this my D? I use what? Line 2 and line 4. Okay? Line 2 is my first premise, line 4 is my second premise. To get my what? D. And which rule gives me this? Modus ponens. Modus ponens is that when you have P implies Q, and you are giving that same P, your antecedent, as second premise, then you can infer your consequence as a what? Conclusion. This is my antecedent, A or C, implies D. D is my consequence. Then this line 4 is already giving us my antecedent. Then I can now infer, okay, that was D as my what? Conclusion. So which gives me what? D. Line 2 and line 4. Modus ponens. So we are not done yet, because this is where we are going to. This is where we are what? Going to. Now, when you need to take note of something, when you are resolving argument using rules of inference, okay, you can use any of the lines, regardless whether you use it before or you don't use it before. You can use it as many as you like, in as much it serves the purpose of what? Arriving at your what? Conclusion. So in as much it serves the purpose as what? Second premise to have, or means by which you arrive at your what? Conclusion. You can use any line as many as you like. And in doing that, when arriving at your final conclusion, you must have touched all the lines before this last line. Okay, let me finish then. You understand what I'm trying to say. So we have my line 3 A, my line 4 A or C, my line 5 D, right? Now we are going to line 6. Lines, and our conclusion says that was A and D. I have touched my line 1, I have touched my line 2, I have touched my line 3, I have touched my line 4. So let me go to my line 5. Now I need to get to my line what? My line 6. Now, our conclusion says that was A and D, right? Which means we have to what? Join A and D together to get this. So there's a rule that gives us this what? That we can use to arrive at this. That is rule of what? Conjunction. Conjunction says that when you have a variable as a first premise and you have another variable as a second premise, you can add both variables together. Okay? You can infer the what? Addition of those variables as a what? As a conclusion. Just that when you have bread and you have what? Beans. You can now say that what? Bread and beans. How do we get now? So we have A in my line 3 and I have D in my line 5. I can now say that what? A and D. A and what? D. You can see I have already what? I have already what? Added A and D together. So which means what? My line 3 and line 5. Conjunction. That's it. The conjunction of my line 3 and my line 5 gives me what? Our final conclusion. So that the one I said that you must have touched all the lines. Now look at it. I've touched my line 1, my line 2, my line 3, my line 4, and my line 5. Before I got to my final what? Conclusion. And look at it. You can see that I used line 3 here and also use line 3 here. That's why I was trying to say that you can use any line as many as you like. And as much to serve the purpose of giving you what? Final conclusion. I hope you are getting it. So let's take another example. So you need to understand these rules and look at it, how they are applicable to what? To resolving arguments. So, okay, 1, E or F and G or H. Okay, line 2. Okay, E or F. So let's say E implies G and F implies. Okay, E implies G and F implies H. Line 3, negation G, therefore H. Now, these arguments now, we are using these rules of inference. Now, there's one thing you need to understand. When you have variable inside brackets, don't get it twisted. You see, it means that everything in this bracket here, like this, and like this, they are one variables. It's equivalent to one variable. This is the major connective. These are the major connective. So this one are just minor connective. So which means everything here and everything here. That is what it means. So which means everything here is equivalent to P. Everything here is equivalent to Q. So that you don't get it twisted by saying, how can I have E or F and G? Somehow B. But here, no. We just have to understand that everything in this bracket is conjunct with everything is what? This bracket. So now, our line 4. So our line 4 says that what? Okay, I can start with any, what's it called? Any line. But here, I want to start with line 1. Okay? So I want to use what I use here, which is simplification. Okay? So we have E or F and G or H. So if I simplify this, to give me what? E or F. Line 1, simplification. So that's one thing. When you have something, when you have words in brackets like this, and you already bring them down, you don't need to put them in bracket again. Okay? Since you've already separated them, you've simplified it. So you don't need to put it in bracket again. Except if you have something here like negation, and you cannot put it in brackets. So line 5. Look at, so this is my line, I've gotten my line 4, E or F, right? Using simplification in my line 1. So my line 5 now, there's something here that is, how will I even say it, that is looking like a roof. here. We have to look at it. We have this our constructive dilemma. I think is the one that's looking at us here. So in our line 2 and line 4, our line 2 says that what E implies G and F implies H. Constructive dilemma here we say what P implies Q and R implies S. So I think the second premise says that what P or R. So if you have to look at it here, this line 4 has already served a second premise for line 2. So we say E implies Z and F implies H. And constructive dilemma says that what when your second premise has already given you the antecedent of this or the antecedent of the second argument here. Then you can infer the consequence of this or the consequence of this. So this is the antecedent of this, which is E, or the antecedent of this. Then our conclusion can be what? G or H. So which means my line 2 and line 4 are the what? As the basis provided to arrive at my what? G or H using the rule of what? Constructive dilemma. I have E implies Z and F implies H. My line 4 has already served a second premise under the rule of constructive dilemma, E or F. Therefore, G or H. So we keep going because that's our final answer. So we have G or H. We have not touched our line 3. Our line 3 is giving us what? Negation of G. So let's go to our rules again. If you look at it, there is a rule here that is what? That is looking at us in this our argument. So which rule is that? Okay, disjunctive syllogism. Disjunctive syllogism says that what? When you have P or Q, and the second premise says that what? Negation of P, therefore Q. Let me use in it's either you are a first class student or you are an average student. Since you are not a first class student, therefore you are what? An average student. I hope you get it now. So now this one here, this one applicable here. We have G or H. Okay? Since it's either you are good at what? Golf, or you are good at what? Handball. And our line 3 has already served as what? Second premise, which is saying that what? You are not good at what? Golf. Therefore, you are good at what? Handball. Line 5 and line 3. Using what? Disjunctive syllogism. You might be wondering why is that? But this one is saying that P, it is the P and Q that come up and this one come down. Yes. Can say it's going to say that because 3 comes before 5 now. 5 now is 5 and 3. It is when it is the first premise. It is the line that you get your first premise that you write first. This our G or H is our first premise and it is in line 5. Our not G is in line 3, which is second premise. So it doesn't matter whether 3 comes before 5 or 5 is bigger than 3. No. It is the line where your first premise is the one that will come first. Then your second premise will be to follow. Then you indicate the rules that you use. So you can see that we've already arrived at our what? Conclusion. Our line 4 is what? Simplification of what? Line 1. Our line 5 is what? Using constructive dilemma between line 2 and line 4 to get this. So our line 6 here is a what? Is using disjunctive syllogism between line 5 and line 3 to get this our final conclusion. You can see that I've already touched all the lines here before I got to line 3. I mean line 6. 1, 2, 3, 4, 5. Okay? 6. So my 6 is our what? Final conclusion. Okay, so let's look at another example. Okay. So let me use this place. Let me use this place. Okay. Z and A implies B. B implies A. Okay. B and A implies A and B. Therefore, actually, because cannot continue, so we have Z and A implies A and B. Okay, so let's go. Like I said, everything in this bracket implies everything in this bracket, right? Sorry, implies B.